Okay, so we're going to talk about the probability involving roll up the rim, which is a contest at Tim Hortons, right? So we did a little research, and we discovered on average, Tim Hortons sells about 3 million coffees every day. So we'll say per day. Okay. Now, probably during roll up the rim, that's probably actually a little bit higher because this is probably taken from an average over the year or something. But we'll just take these numbers to make it simpler for us. So they sell 3 million coffees a day, and we know that roll up the rim, we researched again for this year, which was 2013. It started on Feb, I think 18th?
Yeah, I think that's what you said.
And went to March 17th. Okay, so that's a month, which is 4 weeks. Okay, so the 4 weeks, we got to convert it to days, times 7 days a week is going to give us, what is that, 28, right? 28 days. So this event of roll up the rim lasts for 28 days, and they sell 3 million coffees per day. Okay. Now, the discrepancies in probability, a lot of times, they tell you that you have, what, a 1 in 6 chance of winning? That's what it says, right? 1 in 6 chance of winning. But many people will buy 9 coffees and not win anything. Or you said you've won 5 times and only bought...
Like, maybe 10?
10, yeah. So you're doing way better than what the probability is, where other people are doing terrible compared to that probability. But let's try to make sense of this using empirical probability, which they talk about, and law of large numbers, and then theoretical probability. So the idea here is let's try to actually calculate how many coffees are winners in this case. So assuming that they're selling 3 million coffees a day over the course of 28 days, we're going to multiply these two numbers. Okay, so 3 million, so this is going to be the amount of coffees they sell. So they sell 3 million, a very large amount, over the course of 28 days. Okay, so we're going to multiply that, and we'll just take a calculator out to make this a little simpler. So we're estimating that they sell, I wish I had commas here, but it looks like 84 million. Yeah. So it looks like over the course of this, they're going to sell 84 million coffees. Okay. So in other words, that's the total amount of coffees they sell. So what we're going to do is kind of convert this fraction they've given us. They're telling us we have a 1 in 6 chance. Well, what they did is they reduced their fraction. So they had a 1 in 6 chance, but 6 being thinking of our total number, right? So this is our theoretical probability. And this is through what Tim Hortons has probably made through coffees. So they actually sell 84 million coffees. So we're going to calculate how many coffees are actually winners in this case. So we're going to figure out what this value is here. Well, in order to do this, because they're equivalent fractions, we need to multiply this by some number to get to 84 million. And the best way to figure it out is to actually just take 84 million and divide by 6. And that'll tell us what this number is that we multiplied. And then we'll have to multiply the number on top by that same value to figure this out. Okay, so that's just a couple steps we're doing here. So we have our 84 million. We divide it by 6. It looks like 14 million is the number they multiplied by. Okay, so I'll write it down here. They multiplied by 14 million. Well, and what is 1 times 14 million?
14 million.
Yeah, so in other words, there are 14 million winning cups at Tim Hortons. Great. Okay, that makes sense. But let's try to think about this in terms of practicality, okay? So in theory, this is our theoretical. Let's make sure we spell that right, because I'm not great with that. Oh, no, they don't have it here. Yes, okay, so theoretical probability. They say you have a 1 in 6 chance of winning, right? Okay, well, we'll use some empirical probability. Let's say you're the person buying coffees. So we're going to use this information we have here. Okay, so we're going to do some empirical probability. And what that is doing the testing ourselves. So let's say you are the person who buys all the coffees from Tim Hortons. So in the end, how many coffees are you going to buy if you buy all of them during roll up the rim?
84
million. Mm-hmm. Okay, so you've bought 84 million in the end. Okay, and this is leads us to our law of large numbers, and that's what they call in your book LLN, law of large numbers. Okay, Well, let's say you start with the first coffee you buy, and you have your options of either you win or you lose, right? Well, let's say we win on the first coffee we buy. Great, okay, we won. And then on the next coffee we buy, so coffee number 2, we lose. And then coffee number 3, we lose. Coffee 4, we lose. Coffee 5, we lose. Coffee 6, we lose. 7, I'm going to go 8, and then 9, okay? So we're going to say this just happens, okay? Let's just say that happens, just because I'm sure many people have found this, right? They start with their first coffee, and then they lose. Well, up to this point, they've bought 9 coffees, okay? So we're going to talk about the relative frequency of each of these, okay? So I'm just going to put a little line on top to help us determine the relative frequency. We'll do that in purple. So relative frequency. Okay, well, in the first one, how many coffees have you bought?
1.
1. And how many times have you won?
1.
So in the short term, it looks like you have a 100% chance of winning, which is ridiculous, right? That's not how this thing is working. And then the second time we buy a coffee, what happens?
0.
Yeah, well, we don't win, but how many wins do we have?
Oh, 1.
Yeah.
Oh, okay.
So we have 1 out of 2 coffees. So now right away we've dropped to 0.5, or known as 50%. And it looks like we end up losing the rest of the time, right? So this is out of the 3rd, the 4th, the 5th, the 6th, the 7th, the 8th, and then the 9th coffee. Well, because we only chose 1 win in this case, our probability continuously decreases, it looks like, when we're taking our data. Okay. But eventually what's going to happen is, because we talked about the probability being 1 in 6, and this is kind of the one we were talking about there, that 1 in 6, that's the probability in the end. What's going to happen is if we change these win-loses, I'm just going to change the way we've set this up now. So this is great for what we had. Okay. Let's say that we instead put this as a percentage. Okay. And because probability goes at the highest is 1, and the lowest is 0, and we'll call this was 0.5. Okay. This will have to change now. See, if we won in our first coffee, we were at probability of 1, 100%. Then if we lose on the second coffee, well, then we're 1 out of 2, which is 50%, okay? So I'm just going to change these values now, because before that was just for winning and losing, right? We're at 50%. Well, when we're a third, we've won 1 out of 3 coffees, we're down to 33.3% if we divide 1 divided by 3, okay? And then a fourth of coffees, we're going down to a 25th. And then it keeps going down, but eventually, so in this case it goes down, 1/9 of the chance of winning. But as we get up, it's going to pick up again, right? And because this says it has a 1 in 6 chance, we're going to find out what that value really is. I think 1 divided by 6, 16%. So 16% is, we'll say there, and we'll draw a line across to help us do it in blue. Draw a line across. So here we go. There's the line of 16%. As we buy more and more coffees, okay, what's going to happen is maybe in this course we're going to get closer and closer to this line. Maybe we jump above it and below it, and then we go below again, then we go up, we win a lot, and then we go down. By the time we get to our 84th million, we should be on that value if we bought all the coffees. Okay, so this is empirical. This is from buying all of the coffees and finding the relative frequency. And we stumble around that line because Tim Hortons tell us we have a 0.1 in 6 chance. So what we discovered, okay, and this kind of helps play into the real life. When we did the real life value, on our first 9 coffees, we only won once, which is not a 1 in 6 chance. It was only a 1 in 9 chance. But because of the law of large numbers, the more we buy, eventually, because we discussed how Tim Hortons has 14 million winning cups, eventually we start buying winning cups. And then we maybe, jump above it, go back below, depending on which cups, and we stay up for a bit. But eventually we're going to end up right on that 0.16. Okay, that's the probability of winning at Tim Hortons. Okay, so why does this event happen? Why do some people win a lot and some people lose a lot? Well, we already figured out there was a total of 84 million coffees, right? There are 84 million coffees. How many were winners, we said?
14.
14 million were winners. Right? Which means, how many losing coffees are there?
84 divided by 14.
Not divided by, but
subtract, sorry, yeah.
Subtract. Okay, so we subtract these two. And what are we going to get for losing coffees? We'll call this losers. We'll subtract these numbers. This becomes 0, so 70. There are 70 million losing cups of coffee. Okay, so that means over the course of our empirical data here, go to 100, skip that. When we were buying our 84 million, 70 million times we had to buy a losing cup. So when we only buy 9 cups, well, yeah, 70 million are losing cups. There's a great chance we buy a bunch of losing cups to start. Right? That's the idea of you not actually meeting their 1 in 6 off the beginning. But eventually you'll buy up, we could say, eventually you buy up all the 70 million cups, and then you're only left with winning cups, right? If you happen to purchase it in that way. Say you had horrible, horrible luck to start. You buy all 70 million cups to lose to start. Well, then what's left is the 14 million. But that's why some people might not experience success in the short term, right? And I think they call that in your book, well, it has to do with the law of large numbers, but just because it's a 1 in 6 chance, it doesn't mean in the short term every time you buy your 6th cup, you're going to win. Or out of those 6, you win. It just means that overall, and the 84 million that we guess that Tim Horton sells, that there's 1 in 6 of those, so 14 million of those, are winning cups. But there's still a great chance you grab losing cups because there's 70 million losing cups of coffee in that case. So it is very likely that you do grab that stuff, right? They're just saying overall. So I think that kind of sums up all of those ideas there. Just like what I just said there, because that was a good point. So, because you're kind of fused on how this graph works. So let's zoom in a bit. Let's talk about this. So again, what we were doing here is we're figuring out our percentages, right? So we want our first one, which really represents 100%, right? So you want 100% of the time. But then you lost the next time. So you dropped to 50% of the time you're winning. That's your relative frequency of wins. Then this dropped to 0.33, which is 1 divided by 3. 1 divided by 4 is 0.25. 1 divided by 5 is 0.2. 1 divided by 6 is right on our 1/16th, right? Which is exactly what theoretically we should be getting. But then, we buy our 7th cup, we lost, so we drop below. 8, we drop below. 9, we drop below. And then we buy our other 83 million here, and maybe eventually we go up, down, blah, blah, blah. But in the end, there's 14 million winners if I bought them all. Now, the law of large numbers, 9 cups is not large. So it would have been actually legitimate to say that you had 0 winners in 9 cups, because 9 compared to 84 million is not a large amount at all. Remember, there are 70 million losing cups versus the 14 million. So it doesn't mean that the theoretical probability is wrong. It just means that you haven't taken enough empirical data to get up to that theoretical 1 in 6, right? And let's talk about, try to rate this to every day. 28 days is how long roll up the rim is on. Some people buy 1 cup of coffee a day. In comparison, is 28 cups of coffee a lot compared to 84 million? No. So it's possible you don't ever win. You get 0 out of 28. Right? Even if you buy 2 cups of coffee a day, I think that puts you at 52. 52 is not even a lot to 84. Right? Maybe you only get 1 in those 52, right? Some people might be extremely lucky and they do the opposite and they win 30 out of the 52 times. It's possible, right? But because this number 52 is not playing into our law of large numbers, it's not going to be exactly a 6th. The more we go through the data, then it's going to come down to our theoretical probability of 1 in a 6th. Okay. And so that's why you get that large discrepancy, and when people are playing roll up the rim, they're like, oh, it's not true, I've never won in 9 tries. Well, you haven't bought all 84 million cups of coffee. Yeah, 9's not a large number to that. And that's what that idea is.
I get it.